All right, so we're going to move into our fourth modern theory in motor control. This is our fourth out of 5. And I have 2 articles for you. They're great articles. There is one of them. The first one is by Evans and Stone. It was written in 1995, and it really goes over the literature of dynamic, they call it systems theory. It really is the dynamic action part of dynamic systems theory. Remember, I told you that dynamic systems theory is both systems theory and dynamic action put together. Even though this article talks about dynamic systems, it really emphasizes the dynamic action part of the theory. And then there's an article by Perry, again out of Neurology Report. Both of these are out of Neurology Report, which is what they previously named the Neurological Journal of Physical Therapy. And this actually is a great article, and again reviews, they call it dynamic systems, but it really is the dynamic action part of the theory. The Evans and Stone one actually has an application section, and it's great, and you're going to review this in lab, but we're going to just go over some of the ideas, and then you definitely want to go back and read those 2 articles. All right, so let's get into it. All right, so dynamic action theory. What's interesting about this theory is it actually started as a theory that was used by for mechanical systems, so by engineers regarding mechanical systems. So this first principle then should make absolute sense, and it suggests that there is self-organization and no command center. So there's no brain initiating or activating every part of the motor behavior that we see, that it's really a self-organized system, which is very similar to mechanical systems. All the parts work together, and when one part's finished and does its part, the next part may pick up, but there's a series and steps that the system goes through for a behavior to actually occur. Another tenet of this theory is that movement changes when one of the subsystems undergoes a critical change, that there's a tipping point. And again, this is similar to a mechanical system. So when an arm drops in a mechanical system, its job may be finished and the pattern of movement may change. And so there are these tipping points that indicate that a change is going to happen. And they're usually when one subsystem gets to a limit or is not anymore the best choice for the movement behavior, the behavior that we're seeing. There are also attractor states. So this is a preferred pattern of movement and these are similar if you think to synergies. So attractor states are preferred patterns of movement. Movement patterns that are very stable have deep attractor wells, meaning that just like a marble rolling down a channel, if the channel is very deep, it's very unlikely the marble will roll out of it or do something different. And unstable movement patterns have shallow attractor wells. Another tenet includes the idea that changes in the body, external environment, and changes in the brain and the nervous system actually result in motor development. So again, it's something, there has to be a change internally or with the external environment, and then motor development actually occurs in response to these changes. And again, like I said earlier, this theory has been blended with systems theory to create dynamic systems theory. So when you see dynamic systems theory, it's actually a blend of dynamic action and systems theory, although many times they're not necessarily presenting both parts of the theory. A lot of times they're focusing on one part of the theory or the other. All right, so there are a couple of definitions that are going to be very important when we're talking about dynamic action theory, and these are going to become important, and you'll see them represented in both of the articles that I gave you, but particularly the self-organization matrix. You're really looking at control parameters and order parameters, and you're creating a table with control parameters and order parameters. So you need to understand what these two definitions are. So a control parameter is a variable that actually regulates the change. So it actually results in, somewhere in this change in this control parameter will result in a change in the behavior of the system. Commonly, when we're talking about dynamic action theory, you'll hear velocity is a common control parameter. So if you think about walking, and somebody's walking and they need to increase the speed or velocity of that gait. So for instance, say they're in a crosswalk and the light starts flashing red and they know that they have got to move at a quicker pace or they won't get across the street before traffic comes. So as they increase their speed in gait, there comes a point at which they change that pattern and that pattern becomes a run. And so what is the control parameter that actually results in that change? So there's been some research on this, and we'll talk about this when we get to gait. And so that's the first definition. The second definition is order parameter. An order parameter is what you're looking at, and it's going to indicate the pattern and the instability or the stability of the pattern. So you're actually using this variable to detect a pattern change. So for instance, when in our earlier example of walking versus running, if we want to distinguish between the pattern of walking and running, the difference between those two patterns primarily is that in walking you have a period where both feet are on the ground, or double limb stance. In running, you don't have that period, and you actually have a period where you're off the ground, where there is no contact as you're vaulting from one foot to the next. So that would be the order parameter. As the order parameter, the variability in the order parameter increases, that suggests that behavior is becoming unstable. And at that point, we generally see a new pattern, and the new pattern sort of falls out of the system, meaning the pattern's probably there already. That's sort of the assumption of dynamic action pattern, that all the patterns are present within the system, or the system is capable of producing them. But when you move past this critical period, which the difference between walking and running is the velocity, you get to this critical point, the pattern changes. So again, the control parameter is the variable that drives a change in the behavior of the system, and the order parameter is something about the pattern that you're looking at that indicates the stability or instability of the pattern and indicates a change in pattern. All right, so let's move on and talk about limitations and clinical implications. We're talking about dynamic action theory. So limitations, this theory has been criticized for de-emphasizing the role of the nervous system. So again, because it's talking about how there is no control parameter, that de-emphasizes the fact that the brain may do some bit of organizing of the system, or a system might be organized within the nervous system. So it de-emphasizes that, and it emphasizes the role, the mechanical role of the system itself, or the mechanical nature of the system itself. And it also emphasizes the environment. So how changes in the environment may drive or modify changes in behavior. Clinical implications, changes in movement can be explained by changes in the system and or the environment. And as physical therapists, we want to harness the physical and dynamic properties of the body and the environment. So things like changing velocity, changing weight, potentially adding assistance as far as postural control may allow the system to go through movement behavior in the way that you want to see it. So all of these things that we're sort of doing to the system. Other control parameters that might be important to us are things like orthotics, or devices that help, or assistive devices like a cane, crutches, things like that. Changes in surface, changes in incline or decline. All of those things are potential things that we as physical therapists may want to harness and are control parameters. All right, so what I would like you to do is pull out your table one more time. We're going to fill out the table on dynamic action theory. Again, take a few minutes. Think about how this theory might impact what you're thinking about in your history, how it's going to potentially focus you during your examination, how it might change your thought process for evaluation, and also how it might change what you do for intervention. So fill out the table, jot down a few ideas, and then please get together with somebody in your class, have a discussion, an active discussion, listen to what they're saying, and try to get some new ideas from somebody else. And then once you've done that, you can start up the video again after the pause, and I'm going to have a little discussion about some things that I think impact. All right, so if we think about applying dynamic action theory to the clinic and what we're actually doing as physical therapists, and we start first with the history like we have in the past, we want to, what's going to be emphasized and what we're going to be listening for are any clues that the mechanical system of the body is going to be an issue or might have a limitation. And so you're going to emphasize anything that might indicate damage or limitations in the subsystems. In addition, you're going to listen to if there are environmental triggers or control parameters that cause a change. So those are both things that are going to be important. And so anything in the environment that facilitates for success or presents a challenge. As far as examination, again, you're always going to be examining the task that is going to be the issue. You're going to be looking for patterns of movement. And not only the pattern of movement, but the depth of the strength of the pattern stability. So if you try to change something in the environment, if you try to change velocity or another control parameter, how stable is that pattern? And at what point does the pattern start to get more variable? And not only when it becomes variable, but what is different about that pattern? What part of the pattern starts presenting variability? So what part of the movement is indicating to you that this pattern is becoming unstable? So an order parameter. You're looking for order parameters. As far as control parameters, again, you want to try to introduce possible control parameters. So maybe you're going to use a cane. Maybe you're going to allow the person to run their hand along the wall if you think that stability could be improved by sensory input. So you're actually going to try to change the pattern to a pattern that you are hopefully more satisfied with, or your client is more satisfied with, your patient is more satisfied with, by changing something in the environment or in them. And it could be something as easy as you providing external support. Does that change the pattern? And that would give you a sense if you providing external support changes the pattern in a positive way, then postural control may be an issue. All right, when we think about evaluation, again, you're trying to identify control parameters to get the desired pattern that you want. So what are things in the environment that actually facilitate a change in the pattern? So if you have an undesirable pattern, what do I do to get a desirable pattern? Also, again, you're going to be thinking about what are those patterns that are revealing the point of instability in the pattern, where maybe they're producing a great pattern, and then when they're walking, until they start walking too quickly, and then the pattern, something about the pattern changes. What are the indicators that that pattern is unstable, and what is the ordered parameter that indicates a change in pattern? The other thing that you want to think about in your evaluation is the depth of the attractor well. How stable is that pattern? If I make them move faster, is the pattern stable enough to maintain the pattern that I want? So you're talking about depth of the attractor well. The last thing that you want to think about as far as intervention goes is you want to work towards deepening attractor wells that are in desirable patterns. So any desirable pattern that they're potentially not being able to maintain, you want to strengthen or deepen the attractor well, strengthen the pattern, and you're going to do that through rehearsal and potentially by providing control parameters or using control parameters to increase the rehearsal or the frequency of presenting with that pattern and potentially changing a subsystem, improving control at a subsystem, improving strength of a subsystem, improving range of motion of a subsystem, improving production of a synergistic pattern. So all of those are going to go into intervention. All right, so I think we have concluded our discussion on dynamic action theory. We're going to discuss our fifth and final modern theory, which is going to be ecological theory. So go ahead and look for that lecture, and I'll talk to you as soon as we get into that lecture.